Okay, we're going to try this again. I tried this a couple of times and there was all sorts of software issues. That's why one of you was asking me, I think, why I sound kind of weird on the first few. I don't think you guys understand how strange and uncomfortable it feels for me to just be sitting here in my room just talking to myself. It's a very strange one. But after, hopefully, I think what happened was after a few of you kind of mentioned that you just watched it, it kind of feels a bit less uncomfortable now that I know there will be someone on the other end. I don't know. Hopefully we'll see. Hopefully it reflects itself in the thing, and it makes it slightly better, makes it easier for you guys to kind of know what's going on. I'm not as weirded out by the whole process. But this video is going to be still trigonometry. I did do another video on trigonometry, and I've just kind of finished that myself. It's uploading in the background, but you can't see it. But this is for the trigonometry that is solely for honours level. Leaving cert. If you're an ordinary, you don't need anything in this video at all. So if you're here, you can leave. You can stay if you want. You know, enjoy the maths goodness, I suppose. But in this one, we're going to be talking about the things that we didn't really talk about too much in the other one. Kind of like just some made up bullshit that we have to kind of deal with, like radians. But we'll see how that goes. I think he's all okay with radians. Most of you are actually more comfortable with radians, I think, just because a few of the teachers in Ratatouille do prefer radians. But yeah, so the honours version of trigonometry would be this type of thing that I have on the screen at the minute, the caste system questions, which would, some people call them stack or ASTC or whatever you want to call them. I'll probably call them caste because the majority of you call them caste, I think, so I'm going to refer to them by that. There's also the trigonometric identities, which are going to be kind of bullshit for me to do because there's so many of them that are varied that there's no like one way of doing it that will just cover all of them. I'll give you a few things that will be able to get you most of the marks in them, but I'm not going to go through every single one, obviously. What else would there be? The sine and cos graphs. Now, they are the one part of this that will kind of... Well, no, that's not true. The caste system and the sine and cos graphs can kind of like go on either paper. They kind of pop up in paper one, like as a part B or something. Part C, like just in there in kind of disguise. To be honest, the sine and cos graphs can show up as a whole question. I don't think about it in paper one, but we'll talk about that when we get to that. And the last bit of trigonometry, I think, in the honours is they will sometimes ask a question that looks like this, where they'll say sine of x is equal to something, but they won't ever ask you exactly what x was, like in this question. Instead, what they'll say sine of x is equal to a half, therefore what is sine of 2x or something. At no point do you actually find out what x is. You just kind of like fiddle around with page 13, 14 and 15 of your log tables until it maneuvers around. But for now, we're going to do this question. I'm going to do it out. Again, the whole thing of this was supposed to be more so for your exams, so it's not really going to be me explaining it too much. I can, I suppose, do one of those separately, and because otherwise I know I'm just going to get too into it myself. I will say, when I had the technical problems, I kind of... I think I might have figured out some other kind of things. Hold on, does this still work? Yeah, that still works, okay. So with the software, hopefully it works out. But this is the quadrant, as you guys would kind of refer to it as the Cartesian plane, the x-axis and the y-axis. Right? Now, we don't really use the x and the y in this so much. But the idea you have to remember is this is 0 degrees. The right hand side, that one is just always 0 degrees, and we go counterclockwise. We go in this direction round. So that's 0, this would be 90, this would be 180, and then this would be 270. And then it goes all the way back around to this line again, which is also 360. They are both 0 and 360. And if you want to do it in your horrendous radian format, it would look like this instead. It's all just the same nonsense, but basically everywhere there was a 180 is now a pi. So 360 is 2 180s, so it's 2 pi. 90 is a half of 180, so it's pi over 2. Or, some people write that as a half pi, that's fine as well. And then 270 would be 3 halves of pi. So therefore, or 3 halves of 280 there, so therefore it's 3 halves of pi. Now, so keep that in mind. It says cos of 2 times something gives you minus root 3 over 2. If you remember that it's written like this, A, S, T, C, and you guys remember this, weirdly, you just read it like stack because static doesn't work. Some of you refer to it as cast. But this is quadrant 1, quadrant 2, quadrant 3, quadrant 4, because as I said, we start here, it goes back 90 degrees, always counterclockwise. So we would actually say ASTC, because that's the order that it would be in. Don't forget the A stands for all, S stands for sine, T stands for tan, cos stands for cos, or C stands for cos, sorry. But basically, they dictate in each quadrant, they tell you which one is positive. Here, for example, in this quadrant, only cos is positive. In this one, only sine is positive. In this one, only tan is positive. In this one, all 3 are positive. So, you see here, for example, it says cos of some garbage is a minus number. That means that we want the 2 quadrants where cos would be negative. So, you'll notice cos is positive here and here. Cos is positive in this one and they're all positive there. So therefore we actually want these 2 quadrants because they are the ones where cos would be negative. So we know that we want, I don't know if this is going to mess it up too much, we want just a line in here and a line in here, right? Now, technically there would also be those lines shooting out in these quadrants as well. We just don't care about them because they're the positive versions. If the thing had said plus root 3 over 2, that's when we would have used them. We won't use them. We're going to be focusing on here, but I'm going to draw them all in. Just to point out that we want to find the reference angle, which is the angle you'd go in all 4 quadrants to get to those lines. Keeping in mind we always go from the horizontal line either up or down depending on which quadrant you're in, but you never like come out from these ones, alright? Ever. Do not do it, please. It's just, there's no reason for it other than we just decided to do it this way. It's kind of easier that everyone does it the same way. But let's say, like, for example, if this was like, 15 degrees, we want to know that we go 15 in all of them. And then what we're going to do is we're going to find out what the real angle is, because remember we do like the shenanigans of from here to here is like 180 back 15. So this angle here would really be 165, We always want the angle from 0 counterclockwise. So we actually would want that angle there rather than the 15 in the second quadrant. So what we would do is we'd say, well, in the second quadrant it's going to be 180 degrees, take away the 15, so really that angle is 165. Now, we don't know it's 15, but we're going to figure that out. And the way we figure that out is you always take this guy and you take this guy. You do not include the minus if there is a minus there. Is that okay? Again, sorry, that's just habit. I'll say that a lot. But you don't include the minus. You just include the numbers. If there's not a minus there, happy days, but if there is, you just ignore it. So you take the thing, but you do the inverse of it. So you do cos inverse of root 3 over 2, and then I'm just going to throw it on here just to be sure. So shift again in cos gives you cos inverse root 3 over 2 would be, now I'm going to do it in degrees because it says it here, because I prefer degrees, because degrees are the only sane one in my opinion. So we're going to say 30 degrees. That is the reference angle. Some people would call that the ORA. I probably won't. But that means that we go 30 degrees in all 4 quadrants. Now, what that means is, if I was to do this out again, I've changed something now where that's not snapping to the thing. I'm just kind of curious what else that might have changed. But what that means is, what we're going to do is find the real angles. And what I mean by that is, from no matter which of the lines we pick, you always want to go this way. So in the first quadrant that would be fine, so the real angle there would still be 30, but in this quadrant here the real angle would be this guy. We can't really find that, so what we do is we know this one would be 30, so we say it's like going half a circle all the way to 180 and taking away 30, so this angle would be 150. And then the same down here, but instead it would be like going 180 and adding on the 30, so this would be 210, And then the very last one would be like going 30 in this quadrant would be like so. And it would be going all the way around, almost going a full circle, so only almost going 360 degrees. Take away 30 is 330, right? Now, that's what it would be. Hang on now, I just want to, that's obviously a bit gross. I don't know how I'm going to write that back. Well, tell you what, I'm going to get rid of these because we don't care about those quadrants. Because, as we said, cos has to be negative. So what we're going to do is we're going to find the real angles for both of these two. We know 30 degrees in each quadrant, but we want to talk about it with regards to the entire diagram. So what we're going to do is we're going to say, what's this angle? And it's going to be like going 180 minus 30, so that's going to be 150. And then we're going to say, what's this angle? And it's like going 180 and adding 30 on, so that's going to be 210. Now you can do the rules of, in this quadrant is going to be, theta is just theta, right? That's bad theta. Theta is just theta. Here it's going to be the 180 minus whatever theta is. If you just want, like, if you don't get what I'm doing, these are just the rules that you remember, right? 180 plus theta and 360 minus theta. Again, if you're doing it in radians, you just do the equivalent, but in like the radian version that I did above. You know, instead of it would be pi minus 180 pi, or pi plus, oh my god, pi minus theta, pi plus theta, 2 pi minus theta. But again, I'm going to be just doing it in degrees, and hopefully you can catch up. So basically what that means is, instead of the 2x, we can either put in 150 or 210. So we're going to write that. We're going to say 2x is either to 150, or 2x is equal to 210. Now, this part nobody really likes except me. For each of those, you have to add on a 360n, because, you know, sine of 30 is the same as sine of 390, which is the same as sine of 750. As long as you keep adding on 360, it'll keep going full circle back around to where it began, and the sine or the cos will just tell you the same answer anyway. So what I'm saying is, you could replace that 2x with this and sub in any number for n you want, any whole number, or this and sub in any value for n, and it would give you minus root 3 over 2. And that's why you have to put in the 360n, because of this thing, but don't worry about that. Now, we want to get x on its own, so what we do is we divide everything by 2. Same with this one. Now, you couldn't just do them separately. Maybe I shouldn't have done them both at the same time, if you get me. Like, it's going to confuse people, but 150 divided by 2 is 75. 368n divided by 2 would be 180n, and then the same over here. So these are our two exact values for what 5 can be. I forgot the n. I do apologize. But those are the two exact values. Well, not two exact. Those are the two general solutions. So every possible value of x that we can sub in here, because it's an infinite number, every possible value that we can sub in will be this. To get the infinite list, you just keep subbing in numbers for n from, like, 0 to infinity. You can even technically go into the minus numbers. But they only care about the list in that infinite list, the group of numbers in that infinite list that are in between 0 and 360. So what you do is you constantly sub in, starting with n equals 0, generally. Now, there's a special case, but we'll talk about that. Generally, you just start by subbing in n equals 0, and everywhere then you see an n, you put in a 0. And that will give you a pair of answers. You know, you'll get one for this, and then one for over here. So basically, when you're doing these questions, they come up with a pair of answers, because there was two quadrants. Each quadrant kind of gives you one half the pair. And then that would be 75, and that would be 105, and then you go back again and start to do it again, but just sub in the next number. And we're basically going to just keep subbing in numbers until we get past the boundary of 360. So if I sub in 75 plus 180, there's a way of kind of seeing it sometimes. Sometimes it's harder, and you just have to keep subbing in until it no longer works. I would advise that. I don't know if you guys have done enough of this specific question to know exactly when to stop. But when you do that, what would you get? You'd get 180, 285 even. So those, you'll notice we have 4 answers so far. And then if we do n equals 2, you'll notice that When you do this, though, you get 75 plus 180 times 2. But that is 75 plus 360. Which would be 435. Either way, it's above 360. Which is not what they wanted. They wanted all the x values that are between 0 and 360. Here we're getting an x value that is above 360. So all we do is we kind of just go, yeah, ignore that one. Our answers are here, and here, here, and here. Because there should be pairs of answers. And up until 2018, I want to say, 2019, that's how they always did these questions. It was always just number in front of the x. And whatever number in front of the x there was, it dictated how many pairs there should be. But they changed it. But that's, before I get into it, that's this question. That's the entirety of this question. I did a bit of spiel at the start that you don't really need to do. All this writing, though, you kind of need to do. Maybe not this second graph. You could, maybe you could, shorten down the graphs. The graphs aren't for marks, they're just for your own sake, so you know what quadrant it's in, you know what rule to follow, you remember to do the plusing or the minusing, that type of nonsense. After that, you just get that, and what you could do to check your answer. This is by no means a part of the question, so that's what the rainbow pen is coming out for. What you do is just change the x value into one of those x values you found. So I'm changing the x in the question into 105, and if I type that into the calculator, I would do cos of 2, 105, close brackets, and you get minus root 3 over 2. Yeah, so therefore 1/5 is a correct answer for the value of x, you know what I mean? And it also suits that it's in between 0 and 360. If you had subbed in n equals -1, for example, just hypothetically, you'll notice for either of these, if we sub it in here or if we sub it in here, you'll get a number minus 180, but the number that we're minusing 180 from is smaller than 180, so when you do it, you get a minus number, which isn't what they want for x. So that's why I just didn't do it, right? However, in the two special cases they've done more recently, here, these two, you'll notice these are the two most recent times these came up, 2020, 2021, maybe, and didn't come up in 2022, so probably there's a good chance it come up in 2023, but God knows what variation they'll do. You'll notice in these ones that the angle, and this was the first time this had really happened, the angle here isn't 2 times x, it's theta over 2, and the angle here, you'll notice, is b plus 150, just because they want it to be, they want it to be different so that they can kind of not catch you out, I suppose, but they want to make sure you understand what's going on. It's the same concept. The only difference is at the end, you'll have to do some extra shenanigans. So same thing of A, S, T, C. To get the reference angle, well, first off, what quadrant are we going to be in? You notice it's saying tan would be negative, so what quadrants is tan negative in? Tan is negative here and here, right? A and T, tan is positive, we don't want them. So to get the reference angle, do tan inverse of, again, 1/√3, you do not include the minus. When you do tan inverse of 1/√3, now what they'll very often do is they'll pick numbers that work out decently, that will either give you 60 or 30 or 45. Decent enough numbers, yeah, this is 30 again. Then you do that, you get 30. So that means they want to go 30 in both of the quadrants, if you follow me, but then obviously we need to get the real angles. I don't know if I'm going too fast in talking here, but this is really, you can pause it, you can even want me on slowed down speed, I guess, that's the thing YouTube does. Yeah, again, this is just supposed to be, last minute kind of exam stress. We'll see. But that means that the two values for theta over 2, the two things we could replace theta over 2 for in the actual question, and it would still work, would be if you, I've actually gotten rid of that by mistake, would be the two real versions. So this angle and this angle. And I know I've kind of messed up my diagram, but do you guys get that it would be, one of the suitable answers would be 150, and one of the suitable answers would be 330, and then what we would do then is, don't forget, we would have to then also put the 360n. And those would be your two general, well, we still have to get theta. Thing is, they said, they mentioned that pi instead of 360, so they were kind of hoping, I'd say, people to do this in radians. Now, I will do it in radians, but just know that it's fine if you don't. If you do it in degrees, I think they generally say accept the answer in degrees, but even if you want to play it safe, you can do the entire question in degrees and change it to radians at the end. I should probably mention that at the end, how to do that. Oh god, okay. Just get rid of that, I suppose. I'll change that. So basically, if you do tan inverse, then you're not going to get 30. If you do that, you would get pi over 6, and then instead of doing 180 minus pi over 6, you do pi minus pi over 6. So that reference angle will be pi over 6. That reference angle here will be pi over 6. But as I said, what you do is you do pi minus pi over 6, which, trust me, when you do it in your calculator, will tell you it's 5 pi over 6, or 5 over 6 pi. That works too. And here, when you do 2 pi minus pi over 6, you get 11 pi over 6. And then the equivalent of adding 360n in radians format is you add on 2 pi n, because again, it's just a full circle n. And again, these answers are going to be in pairs. And then what we do is how would you get theta on its own? You'd multiply by 2 on both sides this time. You get me? Because, they'd cancel then. Same on this one. I know it's a bit cramped, but you don't have to do it this cramped, I guess, but you're still going to multiply everything by 2. And then you'd have theta equal to 5 pi over 3 plus 4 pi n. You can just multiply both of those by 2 on your calculator and you'll see it. Obviously with this you can't put in the n, but you just put in the 4 pi, or the 2 pi multiplied by 2, it'll tell you 4 pi and you just slap an n next to it. Here, if you multiply this by 2, it will give you 5 pi over 3. Here it will give you 11 pi over 3 plus 4 pi n. And then we do the same shenanigans as before, where we start by subbing in n equals 0 and just seeing where that leaves us. Now, you'll notice here it says it only wants the angles for theta that are in between 0 and 4 pi. Yeah, if you sub in 0, for the first one you get 5 pi over 3 plus 4 pi times 0. Here you'll get 11 pi over 3 plus 4 pi times 0. Anything multiplied by 0, they'll just disappear, so basically those guys disappear, and we just be left with 5 pi over 3 and 11 pi over 3. Those would be, like I'm working, that's all one thing and that's all one thing. I just kind of copped, maybe people aren't following where I'm writing. Like, I'm envisioning like a line down through the middle of this. Yeah, and then what we do is we sub in n equals 1. And then we'd end up with theta is equal to 5 pi over 3 plus 4 pi times 1. But you'll notice what's happening here is you're basically adding on 4 pi to something, which would immediately make it bigger than 4 pi. So we don't really want to do that. Let's say you don't spot that again. When you add those together, you would get 17 pi over 3. Is that right? It possibly is. And to check it, what you could do is write that into your calculator without the pi. So like, just imagine on your calculator wrote 17 over 3. And when you do that, you'd get 5.6 with a dot on top. But that's bigger than the 4 that would go in front of the pi. You'd get a 5.6 in front of the pi, which we don't want. It's too big. So we would say no to that one. And in this scenario, we actually only have 2 answers that fit 0 and 4 pi. Again, if you did the -1, you'd be minusing 4 pi a single time, which would, would take this into a minus, if you get me. Like this minus 4 pi would be minus something, so we don't want it. It's too small. So our two answers, I'm going to rub that out. Technically you're supposed to have that, but I'm just afraid that it makes the answer look too jarring, so I'm just going to rub it out again. You can rewind it to see what I did, but it was just to see that we don't actually want to keep going, because we saw that the answer would get too big, and this would be the answer they're looking for. If they weirdly ever say, I don't think I haven't seen it in ages, but if they weirdly said write your answer and give your general solutions, it means just finish it here. Don't sub in anything. It's general when you haven't specifically subbed in a value of n. That's what they're going for. This one is slightly different again because it was b plus 150, but again, because this is what they've done the past 2 times it's come up, I feel like the need to go through the weirdness of it. But again, if it's tan of something equals a number and they ask specifically for the angle, it's a cast system. So ASTC, tan is negative, so again we're going to be in this quadrant and this quadrant again. Coincidentally, just the same one. You know, like, there's only so many ways they can ask this, and there's even more limited ways of asking it when they don't want to escalate the confusion too much. They know that if they pick a weird number and instead of getting 30 or 45 or 60, you get like, you know, 22 and a half, shit might go a bit sideways, so they kind of try keep it nice enough, but as a result they only have limited options that they really will pick from. So yeah, again, we want to find the reference angle, so what we do is we do tan inverse again of the bit on the right, but it's not minus root 3, we're getting the root inverse, or the inverse of, we're getting just root 3 because we've already dealt with the minus by picking the right quadrant. We do tan inverse of root 3 and we get 60 this time. Wow. Changing it up again, I'm doing it degrees because it's the only sane way of doing it, but also because they ask for degrees here. The degrees, the 360 degrees thing, as far as I'm aware, comes from the like Iranians, the Babylonians, the old people before modern Iran, and it's, they think they picked 60 because it's the first number that you can get, like, well, obviously you can get 1, but you can get half of, a third of, a quarter of, a fifth of, and a sixth of nicely. If you did 100, that's fine for a half and a quarter, but you can't, and a fifth, but you can't get a third of 100. So that's why they think they use 60, because it works out easier for the first few fractions. Like, no one's really going to be getting a 17th of anything anyway, so you didn't need a number that with that 17 divided into nicely. But generally people would get, like, you know, a quarter or a half or a third or a fifth, so they wanted a number that goes in there. I respect them for it. But now what we're going to say is the b plus 150, I'm probably going to need more room actually because that's longer. The b plus 150 can be equal to, again, it's going to be 180 minus 60, so it's going to be 120, or b plus 150 is equal to 360 minus the 60, so 300. And then don't forget, because it is degrees, we're going to add on 360n to both of them. I'm trying new hotkeys with this just to see if it's easier for me, so that's why there's a bit of stuttering sometimes, but hopefully it's not too intrusive into the video. It's not going to confuse people. You'll notice in this scenario, again, you always want to get the letter on its own, but the way you'd get rid of the 150 is to move it to the other side and make it a minus. So it was a weird one when I did this, but the idea is always get the letter that they're looking for on its own at this point. So it'd be 120 plus 360n minus 150, and b equals 300. Oh god, excuse me, 360n minus 150, and that would just be now this one's going to be, I'll do this one first because you'll notice it's going to be, you can only do like terms, you can't put the 360n in. 300 minus 150 is 150, and the plus 360n is just chilling there because we can't touch it. This one is, you notice, 120 minus 150, so this is weirdly going to be minus 30 degrees plus 360n. Yeah. So those are our general forms, our general solutions. So what we're going to do now is start subbing in. Now you'll notice that all the answers before have been in pairs, and what you would have done here is subbed in n equals 1, and the first one would have been b is equal to minus 30 plus 360 times 0, but that gives you minus 30, and that's not in our realm of what we want. So actually the very first one we get isn't really suitable. We'll come back to it. This one would be 150 plus 360 times 0, which is fine, because you notice when you do that it will just give you 150, which is within our realm, so that's perfectly fine. We're going to keep him. And then common kind of like, you know, practice was to do n equals 1 next. But if you do that, you'll get b equals minus 30 plus 360 times 1, which is why am I blanking on this? 330. I thought something was going to be different. What have I done wrong here? Hang on. Oh no, it's fine, I think. Have I done something wrong? Tan is negative, definitely going to be in that quadrant. I thought I remembered this one giving us a different answer. Maybe it does, and maybe I'm just not awake enough at the moment. I guess these videos might take him more out of me than I thought. I don't know. But I'll have a look. Yeah, I think it's fine. I think it's fine. You do this, and you would get 510, but that is way too big and not in our realm of interest. So again, we just kind of like scrap it. And there's our one pair of answers, the 150 and 330. The reason why I thought I did something wrong here is because I was under the belief that there was one of these questions that what you had to do was actually go back and sub in n equals minus 1 to get another answer that's suitable. You notice if we subbed in n equals minus 1 here, it would not be suitable, because you'd end up getting minus 390, and minus, it doesn't matter, but it'd be a minus number. Unless I'm thinking of a different question, but that's, you know, that's okay. But yeah, as far as I'm aware, that's just the CAS system. That's the entirety of it. You'll notice the questions aren't too huge. I'll warn you though that in paper 1 it can sometimes sneakily show up where what they'll do is they'll give you like a function question. But what they'll do is they'll the one I'm thinking of, yeah, it was like the revenue or profit of a company. So it was like P of T or something was equal to 22. I don't know the actual numbers, which is going to be a problem. 22,000 minus 12,500 costs, I don't know, pi over 26t, we'll say, right? I'm scuffing something up, so when the question's done, it probably won't work out nice, because I'm probably misremembering the questions exactly. And what they do in the exam is, I know it doesn't look like it, but they pick nice numbers that actually will work out decently enough. And this was a functions question, and they said when, like, how much profit will this company make after 3 months or whatever, where t was in months, I think. Or weeks, sorry, t was in weeks, and you'd say t is equal to 3, so you'd sub t in for 3, get an answer. Then they said, when will the profit be a certain number? So what you did was you equated it to that. Like, this is all function stuff. You equated it to that number and solved for t. But the problem when you do that is, like, let's say, no, I remember what it was now. It doesn't really matter. I don't really need to be picking these actual numbers. But they said, for example, they said this, and they said, when will the profit be 12,500. Again, I have to scuff this slightly, but I think I'll get it to work out the same, so it's not too bad. So ignore this, but you put the thing equal to that, you bring the 37,500 over, it becomes a minus, and when you do that, you get to this. That would be minus 25,000, I think. And then to get the cost on its own, you divide both sides by minus 12,500. And then you'd end up with costs of pi over 26t is equal to Well, I've done that backwards because I think they want you to get like a half, not two. My apologies. It's the other way around. Whatever way I've done it, like make them. I don't know. I've scuffed it clearly, but you get what I'm saying. Like imagine I did the right numbers and you got a half here. You'll notice that this bit would become a cast system on its own right. And we'll have two answers. Very often people will automatically just get cost inverse, divide both sides by pi over 26 and get an answer, which is fine. That's one of the answers. And if they say they only need one of the two answers, you're golden. But if not, if it says find the values of t for when the profit is this much or something, find the 2 periods of time in the year when this happens, you'd have to do an entire ASTC question in paper 1. Yeah, like it'd be the same thing. I won't necessarily do it out because I'm afraid I did mess up the numbers so much that it wouldn't turn out nice. But you do cost inverse of half, and we want cost to be positive, so you'd want it in these two quadrants. And when you do cost inverse, you get the reference angle. Cost inverse of a half, I think, is something gross like root 3 over 2. So you'd be going up and down root 3 over 2. So your two answers for pi over 26 t, and I'm pretty sure actually now that I think about it, they did this in radians, not no, I can't remember. But it's still the same process. You put it equal to whatever you got when you did. Well, here it would just be root 3 over 2. That's that's what you're getting. But then for the second one, it would be they did it in a way that it was pi again or something, and this wasn't root 3 over 2, it had pi. I just promise, right? And then you do the 360n or 2 pi n, depending on whether you're doing it in radians or degrees. And it's just a question again. I'm not going to go through it, but just watch out that the cast system can show up in paper 1, but it's in disguise almost. It's kind of hidden. So you have to watch out if you ever get to a scenario where sine, cos, or tan of an angle is equal to a number and they ask for the angle, technically a cast system question. It might be one answer and then you just do it. As I said, without having to go into the cast system. Now, the one thing I wanted to do real quick before I kind of move on is swapping degrees into radians. If you guys remember, 180 degrees is the same as pi radians. That's kind of like the cutoff point. That's the most important kind of identity you need to remember in this regard. Because then, if you are changing, let's say we know it's 3 pi over 2 in radians. If you want to change it into degrees, you just change the pi, you swap it out for 180. And then it'll tell you what it is. It's 270. Because what it does is, what we're saying is pi is half the circle in radians. So what we're saying is get half of the circle and then multiply it by 3. In degrees, that would be the same. It'd be finding half of 180 degrees and then multiply that by 3. Half of 180 is 90. 190 by 3 is 270. If you want to swap from degrees into radians, you would just do what am I thinking? Oh yeah, so let's say you had like 60 degrees. No, we go with 30 degrees. I don't know why. Let's say you had 30 degrees and you want to swap that into radians. You put it over 180, no matter what it is, even if it was bigger. Put it over 180, you get like 1 over 6, and then just slap a pi next to it. Again, some people would do that like as 1 pi over 6, which would just be pi over 6 to some people, even if it was 510, you'd say 510 over 180. That's not right. 540, just to make it nicer. 510 would be something. I just don't have to do that. That would be 3, which would be 3 pi when you just slap a pi next to it. Yeah, you don't need both of them, but I was just kind of copy above. But I bit my own lip there, so that's, ow. Okay, so that's the cast system bit done. I'm going to take a break anyway, so hopefully the cut won't be too obvious like it was last time, but we'll see. Alright, gonna try another one here where we do the we're gonna try to do the trigonometry we did for actual triangles. That's just for ordinary level. Well, what I mean is ordinary level don't need to do this one. Everybody needs to do the triangles with sine rule, cosine rule, all that type of stuff. But this stuff would just be for honours. I know. I think I haven't done this in a while, but when I looked at it, the video that I did in the triangles looked quite long, and I guess you didn't have to watch all of it. Like if I saw it correctly, a lot of it was just examples. So we'll see. But another part of trigonometry in honours goes on, and there's like 4 different things that we want to do. We have to talk about. The first one that I'm going to do is we're going to talk about graphing them. So normally for a sine x and a cos x function, basically what would happen is, we won't go too into the why of it is, but basically for a normal sine and cos graph, sorry, that's slightly not the way I want to. Every sine or cos, no, the basic sine and cos functions or graphs, if you were to put them on a graph like this would be the sine one, for example. It starts in the middle. Jesus, it starts in the middle, and it goes like so. Yeah, I'm gonna want to do this slightly different thing. I'm just goes like so, roughly. I'm sure you've all seen one at this point. If you're at this point, you'll have seen one before. But the sine graph looks like this. It starts at the middle. For a normal sine graph, that means it starts at 0 and it goes up as high as 1 and goes down as far as -1. It never goes up above or goes up above 1 or goes down below -1. And it repeats itself every 360 degrees or 2 pi if you're doing radians. Because then after that, it would literally be the exact same, just the exact same, like copy and paste again, where it go up again, go down again, then go to the bottom loop and then go up again, and repeat itself when it gets to, now I didn't do the graph out long enough, but when it went out to like 720 degrees, so we would say that its range is 1 and -1, because the range is highest and lowest it can go to, and then we'd say its period is how long it takes before it starts repeating itself, how long before the cycle starts repeating itself again, and from where you could like copy and paste and then repeat it forever, and it will just continuously go, and obviously you just keep adding on 360 each time you go across. The range would be 1 and -1, as I said, and it would just keep going, and technically it goes back the other way as well, but we rarely would worry about that. Now we say the period, which is how long it takes before it repeats itself, is 360 degrees. It's the same for a cos graph. The only difference being with the cos graph, it starts at the top instead. So it starts at the top, and that would mean by the time it gets to 360 degrees, because 360 degrees is the period, it would have to repeat itself. So that means that it's going to look something like this. And you'll notice that when you look at it, it's basically the same graph, just offset ever so slightly. Again, we won't go into it too much now, because I'm assuming it's too late at this point, to be totally honest with you. But yeah, it'll be roughly, I know these don't look identical, but they're supposed to be identical, just one is slightly, like it's like you put your hand on one and slid it across to make the other one. And again, this would repeat itself again by the time we got to 720, and it would do the exact same motion again. So again, like with the sine graph, its range is also 1 and -1, and its period is also 360 or 2 pi, depending on whether you're using degrees or radians. Something you want to watch out, or what the main thing is, those are the basics ones. Sine and cos, always the range is 1 and -1, and the period is 360 degrees or 2 pi radians. Always for the sine x and cos x, that's the example. Sine starts at the middle, cos starts at the top. Now, a lot of people want to say, oh, that means sine starts at 0 and cos starts at 1, but we can't say that because the middle, as we're about to see, the middle and the top change. So we're going to keep that in mind, because any of them can be written as, for example, a plus b sine c. Now, I'm using x there, but they can also use t, so I'll do it here, but it is changeable. It's not just that x will always be with sine and t will always be with cos, but they will swap out one. They'll use one of those letters generally. The odd time they use something strange, C could be something as simple as a 3, but it could also be something strange like a 2 pi over 60 or something. You know what I mean? They can be weird with it. But basically each of those three letters, A, B, and C, has something to do with how it looks on the graph. It changes it. The A and the B, these two change its range, whereas the C changes its period. And basically, the way we're going to do it is we're going to, we'll say it like this. A is the new midway line, if you get me. B is what we call the amplitude, which is how much it stretches by. It's kind of where, I don't know, the word amp comes from with guitars. And then C, as I said, C is the only one that changes the period or affects the actual width of it. And basically what you have to remember is, and this isn't in the log tables, you just have to remember that the period of the function is equal to 2 pi divided by the C. Or if you're in degrees, then again, 360 over C. Those are like that, you just have to remember that for the C. These two, whatever number is in place of the A, that just means that on the graph, instead of them rotating around the x-axis or the 0 line, if you get me, in the middle, for example, let's say we had 3 plus 2 sine, we'll do 2x, I suppose. This means that instead of it rotating, whipping up and down above the x-axis, it's actually going to be doing it around the height of 3. So this first number, and if it's a minus, it would just be the same, but down here, it just means it's now the new middle line. And what we would then do is, now obviously when you're drawing it yourself, you won't really necessarily be doing this, or if they give you a graph, they won't have this line. But basically what it would mean is that the new sine or cos graph would rotate around this guy. The 2 is the amplitude, as I said, so that's basically how much from the middle it's going to stretch up and down to the top and the bottom. This does not want to jump to a line for some reason. It'll do. Well, basically, if you go up 2 from 3, you get to 5, and you can go down 2 from 3, you get 1. Now, I know that kind of sounds weird, but if you go up 2 spaces, go down 2 spaces from the middle, because this is the middle, this is how much you go up and down, always, right? Then it would repeat itself. Now, you'll notice that it's 2x, so what you do is you'd say, well, that would mean that for the period, I would have to do 2 pi over 2, or 360 over 2, in which case, in both cases, you get the same answer, but like they're the same thing. It's just written differently. It's 180 degrees or pi radians, right? So what this means is that the graph would repeat itself every 180 degrees or pi radians instead of 360 or 2 pi. So what we would do on the graph is, now for sine, earlier, remember I said sine can't, we're not going to say sine starts at 0 because it doesn't, it starts at the middle. It just so happens for the basic ones, the middle is 0. So for here, sine starts at the middle, so we're going to start at the middle. We know sine starts going up and then loops down and then goes back up again. And we're going to have it come to here. And then it's maybe here, if it's just to eyeball it. And then maybe like here and here. So those are all the points I want to hit. And then I would do this because, again, sine starts at the middle. 3 is the middle line. Goes up 2, so it goes up to a height of 5. And it comes down to -1 at its lowest. And then goes back up again to there before it starts again, before the period repeats itself, before it's the same thing again and again and again. But because we saw about this, it's actually not going to be at 360 or 180. It's going to, or 360 or 2 pi. It's going to be 180 or pi. Is where that would be, and that's the new period. So the range for this guy, you would say the range is 5 and 1, and the period is 180. Or 2 or pi. You guys know at this point they're interchangeable. I'm being overly precious trying to do it. But basically repeat itself again, and be the exact same kind of shape. Yup. Now, with cos it would be the exact same, except it would start at the top. So if literally I did the exact same thing but changed it to cos, it would just be that it starts here and goes down, because cos starts at the top and goes down. And then it would be up here, here, and here, I think is where it would be. And that's what this would look like. but you'll notice its range and period would also be 5, 1, and 180 or pi. So it's it doesn't really matter. That just tells you where you're starting and which direction you're going. The sine or the cos, the other numbers actually are the same regardless. So the number at the very start is the middle line. The second number is how far down you go from there. The c is following the formula on the right. Sometimes, for example, they might just not have a number here. They might just say 2 cos 2x, but what you do is you just imagine that's a 0. Because then obviously that means it's like an original one where it is centered around the x-axis. They might do that. Just be warned, and it will just look like 3 sine 2x, something like that. 3 sine 5x, I don't know. But that would just mean it's centered around the x-axis again. It goes up 3, down 3, and the period would be 360 divided by 5, which is 72. Anything else? So I told you about if there's a minus from the A position, that it would just be the exact same, but it would be centered around this line. Sometimes they could put a minus in this position, in the B position. So imagine if it was 3 minus, I'll just do the same thing again, 3 minus 2 sine 2x. It would be the exact same but flipped upside down. So this blue line represented it, if I remember correctly. That's the 3 plus 2 sine 2x. That's the blue line. Imagine that just completely upside down, and I'll do it in black just because it's severe, right? It would be literally just the exact mirror image of it. Goes down to 1 first, so it's like you go. You mirror image it. If there's a minus right in front of the sine or the cos, it's mirror image. So that'd be the mirror image of the sine graph, because you notice it's the exact opposite of the blue. So instead of going up first, it goes down. That's all you have to keep in mind. All the rest, like the actual figures, are the same. And then if it was a minus in front of the cos, for example, it would be, instead of starting at the top, you start at the bottom and go up, because it's literally just mirror image. And you'll notice that it would be the exact same, just the other way around. They very often will use these graphs to do seasonal things. So they might use like ice cream sales or air conditioning sales. They did one that was the amount of sunlight you'd get on a day in Galway. They do all that type of crack. I think that's the basics of it. There's also obviously the tan graph, but I am not going to talk about the tan graph. The tan graph is something awful, because basically the tan graph, unlike the other two, will do like this type of nonsense, like just continuously. You can look it up yourself. I haven't seen it come up in a leaving cert in a while at least. But basically for tan, I'll write this in, but that's all I'm giving you. For tan x, the basics, the range would be infinity and minus infinity, and its period would be 180 or pi, just to begin with. Now, because the range is infinity and minus infinity, it doesn't matter what numbers really they put in for a and b, because like it's still going to go from minus infinity to plus infinity. That, multiplying the number by 2 doesn't count. It doesn't matter if it's infinity. The period, I suppose, can be changed. If they did tan of 3x, it would just be a period, it'd be 60 degrees, but again, because the infinity thing is in there, it makes it so much more complicated to do, but it also makes it harder for them to ask a question, because the range doesn't really work, and they want to be able to ask you all as much as they can. They want to question you on as much as they can, so they'll probably use, more likely than not, they will use sine cos tan, like 98%, 99% they'd use sine cos tan, or just sine cos and not the tan. Now, I think that's all of it, if I remember it, and of course I'll have jumped back in and said it before now, unless I just completely forgot it and just didn't do it, and then you just won't know, so good luck. But what I'll tell you is that what they do in the question sometimes is, one I saw them do as well was for like, the money a company will make, but like let's say it's the one in the sun, the amount of sun in Galway, and they'll have some, well, I don't know, I'm not going to say what it would be. This is more so for the revenue one. I can't think of actual numbers that might look nice for the other one. They might say the thing looks like this. I don't know if that's going to work out nice, but we'll go with it for now. And they'll say, oh, that's PX for like the profit the company makes, where T is the amount of months the company has been operating. And they'll say, like, and this might be in a paper. Oh, that's another thing. This topic jumps between paper 1 and paper 2. It's one of the few topics that you have to be on your toes for it to be anywhere. Um, you know, but in this, like obviously, if it's in this kind of format in a paper one kind of question, what you might do is it's say how much money did they make, how much profit did they make in like month 3, and you'd sub in 3 for T. But if they say what month did they make, you know, what month did they make 50,000? What you would do is you take the thing and put it equal to 50,000, because you know the formula should give you 50,000 at a certain point. And then what you do is you just keep. Oh, I've completely forgot the sign in the or the cost in the middle. Right? Don't judge me. So what you do is you bring the 25,000 across. Yeah, I might have cut myself off there, but it's basically algebra. That's not like really a part of this topic for at the moment. So I'm just kind of like not too pushed about it. If you bring 25,000 across, it becomes a minus. 50,000 minus 25,000 would be the 25,000. If you agree with me, like just this minus this. Then to get the cost on its own, you divide both sides by the minus 12,500. Now I don't know if these numbers are going to work, so don't necessarily go by this one. This is just like me. I just picked some numbers off the top of my head. You'll notice you get costs of pi over 6 t is equal to minus 2. I did that the other way around. I want to get minus half. Let's pretend it's minus half. Don't judge me. But you'll notice that if you get to a scenario like this, it becomes a cast question. I don't know if I did a cast video yet, but like by the time I get this up, I'll have sorted it, so you don't need to worry about it too much. But it turns into a cast system questions, or stack, or whatever you want to call it. The thing where you have to do the 4 quadrants, and it's ASTC. You have to do one of those questions, and people very often don't realize that. They just kind of do cos inverse or sine inverse and get a single answer and then go grand, move on, which is fine, or it's okay because it gives you one of the answers. But really, to get the full thing, you'd have to do the cast system and get all the answers that they asked. Sometimes what they might do is, and I've kind of put too much on that graph to use it. Sometimes what they do is they'll give you the graph, and it'll be like this, and they'll say, what's the deal with, I remember once they said, like, what's the deal with P? And P is at a height of like 12 or something stupid, right? So basically what it means is, what is P when the Y value is 12? But you notice that that's the third time that it hits the graph. So what you'd actually have to do is, because normally if they want to find out when a function is at a certain height, you'd equate it to that height and then solve it. And that's what you notice we tried to do over here. But you'd get to a cast system question, and I go through it with the cast system stuff, but when you do the cast system, you will get multiple answers. And so to satisfy this one, and to find P exactly, what you do is you do the cast system until you get your third answer, as in you sub in n equals 0 for the first, then you get your 2 answers, then you sub n equals 1, you get your third one, and your fourth one, but you don't care about your fourth one really, so you don't even need to do it. And it might not be the third one, it might be the second, it might be the fifth, who knows. They might even ask one where it asks for the fourth and the fifth. You know, they can be a bit strange. I think that's everything that I really want to say about the cost and sine graphs. Yeah, now there's still more trigonometry. There's cast system. There's the cast system, obviously something else. So I'm not. Don't read into it. There's the trig identities, so like proving the trig functions, which is just not going to be fun to do. And then there's one other bit that we have to kind of talk about that's just kind of like messing around with algebra and trigonometry. But all right. Gonna try doing the rest of the trigonometry topics. I do have the cast system one done. I do have the trigonometric graphs done. I think those are the ones that are kind of the most like kind of information I can give you, the facts, and then like the questions are fairly similar. The things we still have to do for trigonometry are the trigonometric identities, proving them. For example, like anything on pages 14 and 15 of your log tables, I have them here just kind of cut out, so obviously just, you know, the edge bits are missing, but basically those are the mathematical formulas on those 2 pages, page 14, page 15, and they can ask you to prove them, like in this question that came up in 2022, and you notice that is basically this guy here. Yeah, and they're just asking you basically to prove that is true. And kind of the concept with this is you can basically, whatever one they ask you to prove, because they asked us to prove this one, it kind of works in a chronological order, in that like you know, I'm not. This isn't like necessarily 100%, but basically, um, you have to think of it as each of the formulas you see might have been made by the previous formulas, or is only we only know we can get to that point because of the previous ones. So basically, what I'm saying is, if they ask you to prove this one, you can't really be using any of the things that come after it, because that kind of, you know, any of them could have been discovered using the one that we're trying to prove in the first place, and you can't prove something by using something that wouldn't exist if the first thing wasn't true in the first place. Look, it makes sense, right? So you want to use things before whatever one is in a long table. Sometimes that can be hard because the one they give you is like hidden. I think there was one, it was like one of these two they technically gave you, but they rewrote it. They wrote it backwards, so it's hard to tell. But honestly, just try your best with these. Like, I'm not too pushed about these. Some people are like, oh, I don't have to learn every single one of them. I wouldn't, in all honesty with you. It's more a case of we'll try do a few things that hopefully are recognizable for most of them. I've got all of them, I think, from the past like 8 years or something here, or 7 years. All the ones that came up anyway. And I'll run through them and we'll see how it goes. There are some shenanigans involved, but we'll see. Basically, we want to always take the left-hand side. Now, it doesn't have to, this isn't religious, but this is the kind of how I'm going to be doing it. We're going to work with the left-hand side and we're going to turn it into the right-hand side. So they're saying, is this thing equal to this? Well, what we're going to do is we're going to say, well, we know this thing is equal to this, and then we're going to say, and that's equal to this, and that's equal to this, and hopefully down here, we will get this guy, like, in this place, and then we go, oh, it turns out this guy is equal to this, so therefore, yeah, that is true, right? Now, even though that's the way we're going to do it, with something like this, it can be, like, this is pretty complicated to look at. So what I'm going to do is, and I do this myself sometimes, I'm going to, just as like almost a side note to me, this isn't actually like for the exam, this is more so I know I'm going to change everything I see. Every time I see tan, I'm going to change it into sine over cos, because you'll notice if you go to page 13, no matter which one they give you, it tells you what you can transform it into. Tan A is the same as sine A over cos A. So here, if I have tan A, I can change it into sine A over cos A. Yeah, something about that sounded wrong for a second. Tan is sine over cos, yeah. And then you do the same for the B one, but obviously instead of doing tan B, you just do sine B over cos B. And you're going to basically do all of that for all of them. And again, this isn't so much for the exam, this is more so for you, because I think this is handy, because if we know that this can turn into this in one step, we also know it can turn back into this in one step. And instead of looking for this guy, then really we're going to be looking for this guy, and just know that when we get to there, we're basically done, because it's one last step over to here. So it's kind of like finding the second last step by doing this, and it's just a handy way of knowing in the ladder I just did what would the second last one be. We'll be able to work it out from there. So again, everywhere I see tan A, I'm putting sine A over cos A, and everywhere I see tan B, I'm putting sine B over cos B. Hopefully I haven't made a typo there. So that's going to be what we're looking for. That's going to be the second last line we know to look for. But again, I'm going to mess around with the left-hand side until it turns into the right-hand side. Again, anything that's not sine or cos, though, I want to turn into sine or cos. So I know tan of A minus B would be the same as sine A minus B over cos A minus B. That's just following what's on page 13. Tan can be turned into that, and if it's not sine or cos, you probably want it, like, again, most of the time you want to do this anyways, change it into sine over cos, change it into whatever it is, if it's arctan or cosecant or whatever. I know you guys aren't as comfortable with those, but just kind of find out what it looks like over here, and then just like copy it down, right? Because again, sine or cos will be, then it'll, you're more comfortable with sine and cos are more basic ones, it'll just turn into algebra really at that point. What I would do is, at this point, when you do enough of these, you kind of recognize sine A minus B and cos A minus B sound familiar, and that's because you notice before tan A minus B, you have the cos and A, or cos A minus B and sine minus A minus B up here. So basically what I'm going to do is, I'm going to say, well, on top of my fraction I have sine A minus B. Here it tells me sine A minus B can be replaced by all of this. So that's what I'm going to do, and I'm also going to do the same on the bottom. On the bottom I have cos A minus B. I'm going to replace it with what it tells me cos A minus B can be replaced with. So I don't really know how to write this because I don't want to confuse the issue with it, but I would normally write it like this, where I just keep doing equals on the side, as if like I started off with a tan a minus b, and then I'd say, well, that's equal to this, and then when I do the equals again, it kind of means like recurring, like you could just keep, it's like I don't want to just keep writing the tan down the side here, so I'm just going to leave it blank. If you want to do that, though, go for it. You want to write it out fully sideways, go for it. It does not make a damn bit of difference. But basically, instead of sine a minus b, I'm going to replace it with what I said up here, but I do need to see it. So a minus b, in some of the questions we're going to see that the a and the b can be changed for other things, which is fine. It just means that you change the a and the b respectively in the what it says you can sub it in for. Like for example, well, no, I'll get to it when I get to it, or we'll have others copied and pasted already, so I'll wait until we get to that. You'll notice that I'm just going to change this guy as well on the bottom, and because it was cos a minus b, I can literally just type right in what it has up here for cos a minus b. Now, at a certain point when they get to here, people often get kind of stuck, and they kind of think like, well, you know, what the hell do I do with this? Like, there's no obvious step. Up until now, it's been, I don't want to say obvious, but what I mean is, tan, you turn it to sine over cos. Each of these is just a formula. These are their own, this is just nonsense, right? Now, some people would go up and go, well, there's a sine A, sine B next to each other there, there's a 2 in front, but if you do that, it just kind of brings you back to more so this kind of scenario where you have a minus b. Here, all the angles are separated. There's no a plus b, a minus b. Happier days in my opinion, because everything is just a bit more broken up into its basic functions, so it'll be happier. But keep in mind, we want to turn it into this blue thing, and you'll notice that, well, okay, you'll notice that it's a mega fraction like this that has thing 1 minus thing 2 on top, which is what we have here, thing 1 minus thing 2, and on the bottom we have thing 1 plus thing 2, like we have down here. So it's basically already in the right format. We just need to break it down to the blue version as opposed to what we have here in the red. And the trick that I always use is the 1. I single out the 1. This bit down here should be a 1. Now what would we have to do to it to make it a 1? Normally, if you had 6x plus 12 over 3, I think people are more comfortable with doing that, because you would then, I think in people's heads they're saying, oh, you divide 3 into there, and then you divide 3 into there, and you get 2x plus 6, which is fine, but really what you're doing, and it's the right answer, it's just technically what you're doing is you're dividing all of them by 3. Technically. Because then this would become 2, like, you know, 2x, so become plus 6. Technically 3 over 3 is 1, so it'll be over 1, but we just never write the over 1, so that's not what we're doing. But the idea, and I'm not saying you have to do that ever again, but the idea is that you're dividing each and every part of it by 3. Here, I'm going to divide each and every part of it by cos A, cos B, because, and I should have just left room and just cleverly done this later on, so I wouldn't have to write out the whole thing again, but here we are. There's probably a way of moving it using the software, but not one that I can think of at the moment where I wouldn't be just foostering around and moving things back and forth and cursing it out and then, you know. But basically, I'm going to divide each and every part, yeah, sine A, sine B, by cos A, cos B. And the reason why I'm going to do that is because then you'll notice if I divide this one in particular by cos A, cos B, everything here will cancel down to just a 1. Because anything divided by itself is the 1, that's what we want. However, we also have to divide everything else by cos A, cos B, because you can't just divide a single entity in the fraction by cos A, cos B. That would just change its entire nature. Like if you only do it for one part, you're changing like what the actual fraction is. Like for example, if in the previous example I had, where what did I have? 2? No, I didn't. I had 6x. 6x minus 12 or something over 3. If I just decided to, like, you know, half that number, it would just be a completely different fraction. That's just a completely different question. So you can't do it to just one of them. However, if like before where I divide everything by the 3 and you get 2x minus 12 over 1, no. Sorry, minus 4. Was I doing that wrong earlier as well? I don't remember writing a 4. I might have been doing that wrong. But it's irrelevant to the actual question. It was me just trying to explain something I can't remember. But basically, my whole thing is, the whole purpose of this bit on the side here is I'm saying you can't just divide a single entity by another entity. You have to divide each and every single part by the same thing. So because we want this to be 1, in the bottom left, we divided it by cos A cos B, but we have to divide everything by cos A cos B. And then you'll notice that things start cancelling out quite nicely. Now, just, you notice everything cancels out here. That means 1, not 0. The amount of these that just will cancel that out and just say, oh, 0, there's nothing left. But if there is something left, it's a 1. Yeah. Now, I'm going to just write everything that's left. Again, here's your 1. You'll notice nothing cancelled in this one. That's fine. Just going to write it. Now, you'll notice that I've written it before. I wrote it here where it was one big entity, one big fraction, but now it's 2 smaller ones side by side. That's fine. Either or would have worked. But you'll notice that what I've written there is the blue bit. So, even if you didn't spot what to do, you could have just said, oh, well, that's the blue bit now, so I know the blue bit is, I can just write the answer because I got the blue bit. Now, what you could have also done is, well, sine A over sine B, or sine A over cos A is tan A, sine B over cos B is tan B. You know, just replace them all with tan and go back to where you started anyway. But I just don't, sometimes when you're doing it out, you might not be able to see that, so that's why I like to change it at the start to the blue, so that you can kind of have like an idea of what you're looking for. And then you'll know if you get to here, you're like, oh, happy days. Happy days. Tan A and then tan B. Now, that's the end of it. That's the end of the way I'll do it. I'm just going to show you the market scheme because a lot of people are like, oh, I'm just not confident with this. But you'll notice, now I'm going to talk about something else in a second. This top bit in a second I want to talk about is something different. You'll notice that they did it here. There 3 different ways. No, they didn't do it. Sorry, this way. And I don't know. I just think that's my favorite way of doing it. I guess it's just the one that I feel like has the most algebra to it, and I think everyone, not obviously everyone doesn't like algebra. What I mean is it's more common sense to you than like, you know, any other individual topic. So I think it's handy to break it down to algebra. So I would have done it this way, and you'll notice if you did do it this way, for example, you would have gotten 3 marks out of 10 just for asserting the fact that tan A can be changed into sine A over cos A. So something like that, for work of merit, for example, that. So that would have given you 3 out of 10. 7 out of 10 would have been if you wrote this down at a certain point. Now the other bit is for the bit I'm going to talk about in a second, because there is a shadier way of doing it. I just didn't like to show you, but I will explain it. I'm just not going to endorse it, shall we say. You'll notice that if you wrote this down, you would have got 7 out of 10, and that is this line. So at this point here, you would have had 7 over 10, or 7 out of 10. That's yeah, 2 into maths, right? You would have got 7 out of 10 just doing that, which I think is fierce nice of them to give you marks for that stage, which kind of makes sense because the rest of it afterwards is just kind of algebra. So the setting up of it is most important bit. Now I'm going to talk about this part here. You'll notice what they did here is all they said was, well, tan A minus B, which was within the question, tan A minus B is the same as tan A plus minus B. And if you recall, I said in the log tables, whatever one they asked you to prove, you can use anything before it. That includes this one. So all they did was, they just said, well, if I just replace every B in this formula with a minus B, you end up with this. And that's like literally an okay way of doing it. I don't like it for you guys because I don't think you guys know enough about it to be able to know which one to do that for. But basically any of the minus versions here is just the plus version where a B has been replaced with minus B, and that's like technically the proof for it. I just thought it'd better to do this from scratch because again, this is the way that works for all of them, if you follow me, instead of being like, oh, this works for the first one and I have to watch for the second one to include the minus in it. But that's what they did here. They just said, oh, well, I'll just put a minus B in everywhere I see it in the other one, in the plus B version. And then they said, oh, well, I'll have tan minus B's But on page 13 it tells you tan of minus an angle is the same thing as minus tan of that angle. So instead of having tan of minus b's, they change it to minus tans of b's, if you follow what I'm saying. And then that is enough in as of itself as a proof of the thing. Again, I'm not a fan. For you guys, for if someone's doing maths all day, then obviously, but I wouldn't worry too much about it. I would, I don't know. I just think there's an elegance to this, and as we saw, you get 7 out of 10 for getting to hear the bit that was up until there, like quote unquote, as I would have said earlier, like the not obvious part, but yeah. Now there's a bit down here, and this causes consternation amongst us because you guys think, oh, I'll just slap that in my calculator, happy days. But they deliberately do this on purpose, because you notice if you type it in your calculator, you don't get that. You get a different cert form. You get like root 2 minus root 3 or something gibberish, which is not what they wanted. So you have to do this by hand, and it annoys people, but that's just the way it is, because this is the way they used to do it before the calculator. They brought in the calculators, and then everyone could do it for like easy on the calculator, so they kind of went, oh, okay, forget this part of the question, we won't use that anymore. But now it's kind of like they figured out, oh, well, if we write it in a way that the calculator won't give the answer, they can't ask, or they can't just resort to the calculator for that. So what we'll do is we'll put it in a specific form. And that's what they did, and they said tan of 15. And the trick is, tan of 15 you can't do in your calculator. It's not one of the nice ones. But what you had to realize was that tan of 15 is the same as saying tan of 60 minus 45, or tan of you could have done this way as well. Both of these are suitable. 45 minus 30, because both of those internally in the bracket would give you 15, and resort you back to that. And why is it easier to put it in that form? Because basically, if we follow the formula that we just used, and I'm going to actually bring it down so I can just copy it and just explain to you where I'm getting stuff from. I'm going to remove that arrow though, so you don't get confused. But basically, what was I saying? Oh yeah. Before the calculators, we kind of had to resort to these guys. And for these questions, I would suggest you do that, but technically you guys can use your calculators. It's just these guys will look slightly different. Any of the ones that has a root on the bottom will look different on yours, right? So I guess just this one, and this one maybe. Just be warned, it will look slightly different, but it's still fine, it's still suitable. But I'll take this down with me as well, actually, while we're here. But basically for this question, you would have said, oh, 15 is the same as 60 minus 45, or 45 minus 30. Now, you do not have to do both of these. You can do this one, or you can do this one. I might do both of them, just to show you how like both will work. But basically, the thing is, tan of 60 minus 45, is the same as this, except the 60 has replaced the A and the 45 has replaced the B. So I'm just going to write this guy out, but replace the A with 60 and the B with 45 as well. Just to, just copy them basically. So then you can say tan of 60 minus 45, if the rule is true, which we assume it's true because it's in the log tables, but also because we've proven it, it should be equal to tan of 60 minus tan of 45. Just sub into the relevant A and B parts, over 1 plus tan of 60, tan 45. Now the tans here being side by side, maybe I should have mentioned it earlier, it just means they're being multiplied in. This one and this one are being multiplied together. They didn't use brackets because they're not just numbers, so they thought it was okay, and I would agree. Well, I say they, I think that's just me though. They didn't do it. They did it because it was A, but like, you know what I mean. They didn't feel the need to do this, is what I'm saying basically. Which is fine. But then the whole thing is, you can go over here and say, oh, tan of 60 is root 3. So then wherever I have tan of 60, I'm going to put in root 3. And then tan of 45 would be tan, and 45 would be 1. So literally anywhere I put that, or anywhere I see tan of 45, I'm going to put 1. And you'll notice that you get root 3 minus 1 over 1 plus root 3 times 1. Now I am going to use brackets here because they are numbers and you can't really just slap them side by side. You'll notice though you get root 3 minus 1 over, if you rewrite it around just using algebra, you get this, just like multiply this by 1, you get root 3, and then just put that at the front and put this one at the back, just for, shits and giggles. You'll notice it's the exact same as up here, where a is just 3. And that's it, right? And that's literally the way you do it. It would work the same for the other way around. It just takes slightly longer. There's a bit more algebra to it. But that's all it is. And I think a few of you get kind of annoyed because you're like, oh, the calculator's so close to doing it, therefore I'm not going to learn it, which is just a weird take, I find. As if, your teenage angst is going to outdo the leaving cert examiners. They're going to be like, oh, I feel sorry for this kid. No. It's just not going to... I find it funny, but sure, look, I don't really care. We're going to say tan 45 again is also going to be 1, but this time tan of 30 would be 1 over root 3. Now again, you guys probably have it slightly different if you did it the calculator way as opposed to doing it the log tables way. I think it would be root 3 over 3. No, what way would they do it? Yeah, root 3 over 3, yeah. I'm not going to do it that way if that's okay with you. I'm going to do it like this. Which you'll notice looks slightly gross, but in the same way earlier we divided everything by cos A, cos B, and I was, in my example to prove why that was allowed, I was dividing everything by 3. We can also multiply every entity by root 3. And I'm going to do that here. That's a 3, I promise. That's a root 3. This is a root 3. It's okay that I'm multiplying in front. Multiplying can be, it doesn't matter what order you do it in. But you notice each of those gets multiplied by root 3. That would cancel, that would cancel. And what you end up with is root 3 minus 1 over root 3 plus 1. Wow, crazy. It's all just fun and games, really. Now, I'm just going to get cracking because, again, I have more of these. And you can just pause, rewind, whatever. I'm sure, unless something tragic has happened to me, I'm sure I've told you that you can always just, send me a message and I'll try voice respond or something. Unless you've annoyed me, in which case, But for now, I'm just going to try and move on, and we'll see. Now, I probably need... no, I don't need any of the others. This one is trickery shenanigans in a head. It's just all over, right? So you see this 2a. The 2a, again, if it's not cos or sine, change it into cos or sine. Not present, really, here. Cos squared and sine squared are fine. Quick reminder, you remember sine squared a is basically the same as sine a all to be squared, but they were afraid that people were going to kind of confuse that with this scenario, so they just didn't write it like that, because if you say it sine a squared, it can be this bracket, or it could be this bracket instead. So they came up with this way, sine squared a, just to kind of avoid that problem. It's not the end of the world, just I guess I'll leave that there. Yeah, the trick here is the 2a. We obviously want it to be a, because 2a is just not the same. And a common trick involves, everywhere you see a 2a, you can, I'm not saying you necessarily have to or should, change it to a plus a, because if you think about it, a plus a is 2a. And then you'll notice that, again, using literally the same formula we kind of would have used before, we have a formula for cos a plus b. Now, the thing is, though, it's like the b has been turned into an a, so everywhere I see a b, I'm going to turn it into an a as well, if you follow me. Now I'm going to take that down, and hopefully I don't automatically write in a b, and then remember halfway through it, and cos a minus sine a. But what's x by x? It's x squared. What's cos a by cos a? Be cos a squared. Same with the sine. But then, as I was kind of hinting up here, highlighting up here, that just works out to be this. Now the minus was at no point involved in the squared, if you get me. It was kind of in between the two things that are being squared. So it's not a case of you have to square the minus at all, so that's fine. Is that, again, I was going to say, is that okay? Just because I say that to you guys all the time, and it's just going to have it. That is okay, right? That's just the answer, all right? Now here, what were they doing? Oh, using the formula you've just proved, find the value of cos theta. And they told us sine theta over 2. that's probably a big hint, the fact they told you sine theta over 2. So they probably want you to use the idea that A is theta over 2. You can, in this specific example, they wanted to replace the A with theta over 2, because then we would, this would make sense. I think that's right. Let me just see. Yeah, because then what you do is you'd say cos, instead of saying 2A, you'd say 2 theta, that's a theta, over 2 is equal to cos squared. Oh, they're mixing in another bit that I wasn't really going to plan on doing just yet, but I guess I'll throw it in. Cos squared. Okay, yeah. So basically, I'm just using the formula from before, but they kind of hinted that just swap out the A for theta over 2 because they said sine of that. Now, the idea here is, this was a weird one in particular, because you notice the 2 and the theta over 2, the 2's would cancel and you're just left with cos of theta, which is handy because they said they want the value of cos of theta, so fine, for doing cos of theta equals blah, it's fine. Now, cos squared of theta over 2 we cannot do yet. The sine, however, if you recall, that's the same as the big thing, like that. So really what I can do is I can change this into 1 over root 5 squared, because they told me that anywhere I see sine theta over 2 I can replace it with 1 over root 5. Because it was being squared, I just had to put a squared on the end of it. Now, the ideal scenario is if we could do the exact same thing. Like if they had said cos theta over 2 is equal to blah, we could have also just subbed it in here and squared it, and we would have been happy days, because you would have just put it in the calculator, got a number, and just moved on with your life. But they didn't. And very often what you have to do here is, this is kind of a hint. You'll notice they said theta has to be between 0 and pi, which is the same as 0 and 180. This is pi over 2, which means that it's in between 0 and 90 degrees, if you think about it in degrees. I think people would be more comfortable with it. If they tell you that theta has to be within 0 and 90 degrees, or 0 and pi over 2, I guess technically, what you do is, and this is the bit that I wasn't, this is like the fourth, what I would consider the fourth kind of part. Imagine a right angle triangle, where this is the angle. In this scenario, if you recall, this is the hypotenuse, the opposite and the adjacent. That's in another video, I'm not going to go too into it. But basically, when they told us sine was equal to 1 over root 5, in our rhyme, sine is equal to opposite over hypotenuse. So if they told us sine was equal to 1 over root 5, that means that we can replace the O with 1 over root 5, and we can replace the H, whoops, completely arseways. We can replace the O with 1, and we can replace the H with root 5, because that's like the H was on the bottom, the O was on the top. So that's where I got those two numbers from. And you mightn't see it just yet. But then what you do is you do, just like bear with me for a second. What you do is you do Pythagoras. I know you don't like these letters, boo-hoo. You do Pythagoras like so, to get the third side. You'd get 5 equals 1 plus a squared. 4 equals a squared. You get square root of 4, because the opposite of squared is square root. You'd say, oh, the a is the 2 then. So that means here's 2 in this wonderful triangle. And what that means is we can go back here, and cos, according to our rhyme, cos is equal to a over h. Which, according to our triangle, if we want to do the same, is 2 over root 5. If you follow me, literally just the a number over the h number. And then here we can go back and say, oh, that must have been this. This is 2 over root 5. So here, where it was cos, I'll write it out again. I was going to be cheeky and just rub it out again, so I didn't have to write it out. But I know I use it to throw a little flip out. Here, instead of cos then, I'm going to do 2 over root 5, but I do have to stick a squared on the edge because it was being squared. But then, you can just throw that in your calculator, because it's all just numbers, really, and you'd get 3/5, I think. Yeah, I think that's right. Now, like, it's late, alright? Don't, like, I'm trying. But basically, if they kind of give you a hint that theta is in between 0 and 90 degrees, or 0 and pi over 2, and here they didn't say that, but they did say the angle is technically half of this, if you follow me, because it's over 2. So really that's kind of a hint. You set up the right angle triangle, you put in the 2 bits of information you would have known, whether they tell you the sine or the cosine. I can't imagine they'd ever tell you the tan, but if they did, just sub it in as the O and over the A, and find the third one, because then you'd be able to create any of the trigonometric ratios, any of sine, cos, tan, sub them in relevant. Yeah, so cos of theta is 3/5. Okay, now again I'm just going to move on. Just, I don't want the video to be too bloated, because I know you guys don't want it to be too long to begin with. Me neither, to be totally honest with you. This one is fairly similar. This was another year entirely. I'm putting them next to each other, but it's not connected at all. But you'll notice it's actually quite similar, because it's cos 2 theta without even looking at the rest of it. I can just say, oh, cos 2 theta is the same as cos theta plus theta. And that is the same as up here, where we have theta, or well, cos A plus B, but where both of the A and the B have been replaced by theta. So I'm going to write out what it's equal to, and then just replace the A and the B. Oh yeah, now there's going to be some shenanigans here that I haven't mentioned yet, and I was going to mention it, but they've kind of again just rushed me into it. I didn't plan this out too much, alright? I just kind of copied and pasted the things, and we're just running through them as we see them. Again, in a similar fashion, these guys would then be like, cos theta squared minus sine theta squared, which would be like so. Now, you'll notice that this is kind of like that would be acceptable almost, but they very specifically wanted it as 1 minus 2 sine squared theta. We have a sine squared theta, so he's probably fine. This guy, though, needs to go. He is a problem, because you notice they don't have any cos squareds in here. Now, we haven't looked at it yet at all, but one of the most commonly used ones is actually on page 13. Oh, it's bringing everything with it. Okay, sick one. 13, because on page 13 on the top right, this guy is super important. It says that cos squared of an angle plus sine squared of that same angle is equal to 1. And what that means is, for example, we wanted to get rid of a cos squared, so what we could do is move the sine squared over and make it a minus, and then we could come up with the equation of cos squared A is equal to 1 minus sine squared A. Just because you move it across, that's fine. Still the same formula, just written in a different way. It'd be like saying, instead of saying 2 plus 2 equals 4, it'd be like saying 4 minus 2 equals 2. It all makes sense. But then what it means is here, I get to change this guy into 1 minus sine squared, just because that's what the thing says I can replace it with. And then the minus sine squared that I said was fine before he's just chilling down here, so he's fine. But you'll notice that what you're left with is 1 minus 2 sine squared theta, which is what they wanted. So if you see a sine squared or a cos squared, just be on your toes that you might need to use the rule on top right of page 13. You don't always. You'll notice here I didn't. Technically you could have here actually and avoided going into the triangle, because you could have changed the cos squared into 1 minus sine squared and done it that way probably. I feel like that's not respecting the integrity of the maths, but when has that ever stopped any of you before? Which one will I do first? I'll do this one first, because this one is extremely similar to the right angle triangle, because again, you'll notice they say A has to be between 0 and 90. Hint, hint, right? They also tell you a description of what cos A is and ask you for another one, sine 2A. At no point, now, the way you can tell these aren't casts questions is because at no point did they actually ask you what the angle A is. At no point did they do that. They say, oh, cos of A is this, and what is sine of 2A? There is no, you're kind of you're bridging from one to the other without actually figuring out what the bricks are made of. You're just kind of sorting it out like that. So what your job is to do is to find a formula that looks like it has cos A and sine 2A. Again, I know I have to scroll, but what are you going to do? You'll notice, what did I say? Cos A and sine 2A. You'll notice that, is that what I said? Cos A sine 2A. You'll notice that here's a sine 2a, but it has tans. That's tragic. You'll notice here's a sine 2a. Yeah, that's the one we're actually going to use. Was there another one I was going to point out that you could have used, but I'm not going to? I don't think so. But we can say sine 2a, just the second one there. Sine 2a is equal to 2 sine cos. Let me just make sure I remember that. Sine 2a equals 2 sine a cos a. And you'll notice, again, that's handy because now we have sine 2a is equal, which is what they wanted. Oh, yeah, now they said in terms of y. We're not going to get an actual number. We're not going to say, oh, sine 2a is equal to 7. Wow. We're going to get it as, like, it just has y's in it. So we're going to say sine 2a is equal to this. We know the cos a can be replaced. So we can say equals 2. For the cos a, I can put y over 2 in. Now, we also want to know what the sine a is, so we know what to replace the sine a with. In order to do that, we take advantage of the fact they tell us that the angle is between 0 and 90 and set up a right angle triangle. And we say, again, this is a right angle here. I always just pick the bottom left to be the angle here because, like, it doesn't actually matter. You're constructing it yourself. There's no wrong way to put the angle in, really. And also, this isn't for the marking scheme. This is just for you. If the angle is there, then we've got the hype, the opposite, and the adjacent. Now, the one they told us was cos of a is equal to y over 2, but cos, according to our rhyme, is a over h, I think you'll find. So here, instead of the a, you can change it to y, and instead of the h, you can replace it with a 2. In order to do sine would be o over h, according to your rhyme. So we need to find out what o is, so that we can then sub in. We know that h, for example, is going to be a 2, because of here. But what we're going to do now is we're going to find out what the o is. Now, we're going to do this using the Pythagoras again. It's not... sorry, I messed that up immediately. It's not... people weren't overly pleased with this one. I am going to use... I guess I'll use OPP for opposite here, right? But you'll notice that what happens is this becomes 4 equals y squared plus OPP squared. 4 minus y squared. Now again, we don't want the opposite squared, we want the just opposite on its own, so the opposite of squared is the square root. So, the opposite was the square root of 4 minus y squared, and I feel like if people did actually get that, they were like, something's gone wrong here, this can't be right. So the sign would have been 4 minus y squared, square root of that, over the 2, that was the h, if you remember. We're just filling in the sine a formula here, because now we can go here, and instead of the sine a, replace it with the square root of 4 minus y squared over 2. This 2 and this 2 actually cancel, and you're left with, yeah, just this will do. You could argue, oh, you could put the things together as a fraction, but to be honest, at this point, who really cares? Because you know, it's already, you know, technically, people will be, oh, you could change it to this, and they'll all feel high and mighty about it. But like then, by that logic, you could change the whole thing to like 4y squared minus y to the power of 4 over 4. You know, where's your God now? So, we're not going to do that at all. Do not worry about it. Just other things you can change it into as well. The last thing I'll do then on this video, unless there's like, you know, another issue I run into and then I kind of frantically have to go back to it. Oh yeah, this one. Now, this was the furthest one to go, I think, because it's the last one I have down, so it's probably the longest one away. That could obviously mean that it is coming up, because they could be cycling around, or it could be that they went, oh, that's garbage, we're never going back to that. Now, you'll notice, again, cot 3a, I'm going to hack these lads down here so I don't have to keep scrolling. Cot 3a stands for cotan, right? So again, it's a version kind of tan. It's like the inverse of tan. Not the inverse, that's a different thing. Do not get them twisted. What we're going to do is we're going to go here and see, oh, cotan of a is cos a over sine a. It's like the upside down version of tan. So again, in blue, I'm going to just say, oh, that is, instead of sine over cos, it's cos over sine. And then when you change it to, the angle has to remain consistent. So because I'm changing it to sine over cos, it's still going to be 3a because the initial angle was 3a. So the thing is, though, these angles do not match. The 7a and the a, you know, we want 3a, so there's something screwy there. So what we're going to do is we are going to go over here, and you'll notice, and I know it's kind of annoying that I just kind of like know this, and you're kind of like, but how do you know to do this? You just kind of have to look at it, you have to do enough of it, and this is why I don't really like this topic. A lot of it is just kind of like, unless you learn every single thing they could give you, but you'll notice that this thing they're giving us isn't necessarily on these pages, so it's just like, they can just come up with some crap and just throw it your way. So that's why I don't like looking at these too intensely. You want to like kind of look at it enough to be able to give it a shot. Look through the log tables, look through these 2 pages here, see if there's anything. Everything else is in sine and cos if you kind of ignore that and treat it as cos 3a, sine 3a. So all I would do is I'd go, well, cos a plus cos a or b looks like this crap. And on the bottom we have sine minus sine, which looks like this crap. So I'm going to just use those two, but adapt them obviously, because we have 7a and a in place of the a and the b. And I'm just going to replace them in kind of like their equivalent as so. I think you guys can read that, right? If you put it on a big enough screen, you could. If it's on your phone, yeah, if it's on your phone, you're probably never going to read that, but that's on you, I guess. All right, I don't know. Well, now I feel bad. But what we would do is cos 7a plus a. I'm just going to like replace the a with 7a. I'm going to replace the b with another a. And then write out this, which is just like the same. So 2 cos, but again, 7a plus a instead of a plus b over 2. And then there's no sign because it's just being multiplied. Cos 7a minus a over 2. Controversial. Now on the bottom we have the sine 7a minus sine of a. So again, I'm just going to write out this guy, but just replace the a and the b as such. 7a plus a over 2 sine 7a minus a over 2. You'll notice that you know, the 2's well, we won't do it just yet. So we have 2 cos on top. 7a plus a is 8a, and 8a over 2. Like, you know, you can do this first. I'm just going to skip it so I don't have to write it all out twice, if that's okay, because it's a pain in the arse to do it here. But 8a over 2, like I wrote, and you can go back and look at it again if you're unsure, is just 4a. Cos of 7a minus a, again, I could write it as, I'm giving it away, I could write it as 6a over 2, but I'm not gonna. I'm just gonna jump to the next one. Again, you can write that if you want to, but I know 6a over 2 then breaks down to 3a in the second line. Please don't make me do that again. Same kind of shenanigans on the bottom occurs, and you get like this. You can go through it bit by bit if you want. I'm not going to judge you. No one's going to judge you about that. You'll notice though, cancels, because we have a 2 cos 4a and a 2 cos 4a on the top and the bottom. The cos 3a over sine 3a doesn't cancel, but oh look, that's what we wanted. So now what we can do is we can just say, well, that just turns into cotan of 3a. And I think that's the beauty of setting up kind of like the weird answers sometimes. You kind of know what the second last one is to look for, because it's very hard, a lot of the time, to go from like here to here. Kind of like, well, what's the next step? Like, what do I do? So I always kind of like having that, so now we know just to get to here instead of getting to here. And we can, it's kind of cutting out one of the steps going down the ladder, if you follow me, and we just kind of know. We know where to be safe. Now, again, I'm going to do this again. Sorry it's so long. I don't really kind of intend it to be so long. It's just, you know, doing the best I can, trying to get as much of it in as possible. If you have a problem, you can obviously skip the stuff. But it says here, given that cos 2 theta is equal to 1 over 9, what is cos theta? Again, they never ask for theta. They specifically ask for it in this form, which I think screwed people up a bit slightly. But again, it's to avoid you just putting it into the calculator, figuring out what theta is done, and then subbing it into cos. So what we're going to do is we're going to look through the things again and try to find out one that connects cos 2 theta and cos theta. Now, I don't know if you guys can actually see it. It's actually going to be this one. Yeah, now technically, again, you could use that one and swap it around. You know what I mean? There's more than one way to do this, but I'm going to use cos squared a. I'm going to use the third one just because I'm going to go now in a second. We have cos squared a equals a half. There's 1 plus cos 2a. Now, again, you'll notice that now they have a. We can just replace all those a's with theta. It's just a different letter. It's literally, that's all it is. So like this would just become a theta, this would just become a theta. It's the exact same shit. If you recall, cos squared theta is the same as cos theta squared. So what I'm going to do is I'm going to replace the, no, I won't, I'll write it out. Cos theta, all to be squared, is equal to half 1 plus cos 2a, cos 2 theta, sorry. Cos 2 theta we know is 1 over 9. So we can have it like this, which is 1 over 2 times 10 over 9, which is 5 over 9. I think you can all just draw that in your calculator. Is that right? Oh yeah. Because don't forget, it's still equal to cos theta all to be squared. But then the opposite of being squared is if you move square theta to its square root, so you get cos of theta is equal to the square root of 5 over 3, because if you put that the square root of this guy in your calculator, it'll oh, will their calculator do that? I don't know. But basically the square root will apply to the top thing and the bottom thing. The bottom thing being the square root of 9 would just be 3. Top thing being the square root of 5, it does not work, so you cannot do that. So you just kind of have to like throw it out there and just leave it in the ether. And they say plus minus, you can just put a plus minus in front of it, because technically the square root gives you a plus and a minus answer. We would not be worried about it too much at all in the slightest. Is that everything? That is everything. I'm going to bounce.